Hello, welcome. Thank you so much for joining this webinar. Today, we are very excited to introduce the first ever 650 watt DC driver. Yeah, first I would like to introduce myself. My name is Indu Kapoor. I am a product manager for Linear Driver. I am a part of OEM business and I am based here in Eindhoven High Tech Campus, Netherlands office. With me today, we have Ulri Buck. He is a part of research and innovation team. Ulri has been working on this product since last 4 years, and he was instrumental to develop the first prototype of 650 watt DC driver. Ulri, welcome. Thank you so much for joining us. Would you like to share your thoughts?
Yeah, thank you very much, Indu. Yeah, it's really an exciting topic here. These type of DC grids that we will introduce you allows us to make our lifestyle, our way of working more energy efficient. Yeah, and that's a super cool target to work on.
Thank you. So with that, we move forward. Now, what we are going to cover today. So we have multiple topics we will briefly touch upon. So first, we are going to share the benefits of 650 watt DC driver. Why at the first place do we need a 650 watt DC driver? We have a standard AC drivers. Then we are going to share about the application. What are the application needs? What are the application criteria? We are going to share the electric systems. What are the protection criteria? And what is the lighting effects here? In the end, we will also take some time to take your questions. And therefore, at this moment, I would suggest, in case any question pops up, feel free to write your questions on the chat icon, which you can see on the screen on the right side. Yes, with that, let's talk about the first 650 watt DC driver. Now, you may have this question, why we are talking about it. We have been so vocal. We have been sharing multiple posts on social media. What is so groundbreaking about this product? So before I share the impact with you, I am going to talk about the journey of this product, because the journey really amazed me. You may think that, okay, since we have launched the product recently, we must have developed it maybe 2 to 3 years ago. But well, that's not the fact. In 2009, we developed our first 48 watt DC driver, which we installed in the research lab in Aachen, Germany. After that, for 4 consecutive years, we were the part of EU Open Innovation Project called DCCG, which is DC Component Grids. With all the learnings, in 2021, we dedicated a task force team, which was specifically with the vision to make a first prototype of 650 watt DC driver. And in 2023, we came up with the first 650 watt prototype, which is, as you can see, is 420 driver. It's a very big housing. Now, some interesting facts about this prototype. So we installed these prototypes in 4 different locations in Europe. And in each location, for now, 15,000 hours, these drivers are up and running. Now, with that, of course, the obvious moment was, when are we going to launch this product? And that's when we decided that, yes, the market is ready. We see some of the early adopters, the leaders who are moving to 650 watt DC grid systems. And that's when last month we launched our first ever 650 watt DC driver. As you can see, this is in a smaller housing. This is 360 driver. So the previous prototype was really big, and this one is small. Now you may ask, okay, what is the future? Now, in my understanding, the future is DC systems, which means the industries will shift. And when the industries will shift, that time we are more than ready. So here, and that's the reason why I say that this is a groundbreaking product. This is a futuristic product. Now, Ulri is going to walk you through to all the details, but I would like to just share about some product key benefits. So yes, it's a 100-watt driver. My customers keep asking me, what is the efficiency level? In this case, it is 95%, which is tested at maximum output power at rated input voltage. What about the lifetime? In this case, it's 100K hours. The product is simple set, which means NFC ready. This is a sensor ready product, which means it has integrated bus power supply. It has other DALI parts, which allows luminar data, energy reporting, diagnostic and maintenance. These drivers are suitable for class 1 luminar, and it is box programming enabled. Now here, as you can see, the size of the driver, which is 360 mm length, 30 mm width, and 21 mm height. With that, I can hand over to Ulri to share more details. So the virtual floor, over to you, Ulri.
Yeah, thank you very much, Indu. Very welcome also from my side. So in the following, I will go for you into the benefits and applications and some details of lighting systems that makes use of these 650-volt DC power systems. The interesting topic of direct current power is the efficiency advantage that maybe some of you know already from electric cars or from trains. Practically, these transport systems can reuse the braking power of their electric motors for other use. And this reuse of braking power, to make our life more energy efficient, that can be used now also in industrial production. And there, most likely you would use the braking power of electric motors, for example, in lighting systems, because very often lighting systems are the second largest electric loads in production facilities after the electric motors. Luckily, about 70 industrial and academic partners of the Open Direct Current Alliance have developed this DC power infrastructure. In contrast to classical 230-volt AC or 400-volt AC main system, the DC grid offers interesting benefits such as lower energy cost, thanks to the higher energy efficiency of the complete installation. That's due to the reuse of braking power from the electric motor drives. Further, the power level that the factory then consumes from the public electricity grid can be reduced, and that's also an item where factory owners have to pay for. So second item where you can reduce the operating cost of factories with DC grids. Further, the resilience and robustness of operation of production sites can be increased when the DC grid also make use of energy storage components such as batteries. This is especially of interest when you have your production not only in Europe, but also in other parts of the world where the public AC grids are not that robust as here in Central Europe. The best-in-class use case of a 650-volt DC power systems you can find currently in our view at the company Schaltbau and their brand new next factory in Germany. Schaltbau is a manufacturer of electromechanic and electric power protection components, and they are doing it already since 1929. So they know the business of electricity grids, AC and DC, very well. We will look into the details of their achievements in their next factory on the next slide. The technical properties of these more energy efficient use of electric power luckily documented in a book that is illustrated here on the right. And the good thing is you can download this book with 200 pages free of charge from the webpage of the Open Direct Current Alliance, where you see a link at the left lower part of the slide. For your information, we will provide you after this webinar all these references that we show here on. Yeah, the company Schaltbau is using DC power systems in their brand new next factory in Velden. The maximum use that we think you can get from it. And we are very happy and appreciate the approval of Schaltbau to present their results here in the factory. This factory combines production as well as a warehouse and office areas on 17,000 square meters. The biggest savings Schaltbau has made is a reduction of the peak power loads in their automated high bay warehouse system by 85% compared to former warehouses that they have operated. So this is really a cool saving. For the complete building, so production, warehouse, and office area, the building has shown 35% less energy consumption compared to the use of former AC installations. Further, the company has achieved 30% less peak power at their AC mains connection. That reduces the cost of the AC mains connection accordingly to this savings. Yeah, due to this super achievement that the company Schaltbau has realized in this new production site that has opened end of 2023, the company is very correctly awarded then also with the Energy Efficiency Award 2024 of the German Energy Agency. The details of this building as well as other use cases for the application of 650-volt DC power systems in production sites you can find here at this presentation slide. These efficiency advantages that I have summarized can be used in the best way in digital and automated production with robots or with multiple motor drives. And examples for such production systems are, for example, automobile production, the production of battery cells, solar cells, semiconductors in generally, where a huge amount of robots are used, clean room areas. You find huge amount of motor drives also in steel and paper production. These are very long factory lines where a huge amount of motors transport then steel through the whole factory. And last but not least, a little bit other application where you use a lot of motor drives are container terminals that can also benefit from the DC power systems. In all these applications, a DC powered lighting system has then the special feature to reuse the braking power from these motor drives. And once you use the braking power from motor drives to power your lighting systems, you need less energy from the public grid in your lighting systems and similar applications. Next to these production sites, also buildings with high peak power loads, for example, from electric car charging, for example, in supermarkets and shopping centers, yeah, especially in the parking houses next to the supermarkets and related charging stations. That's another nice application where you can benefit from managing the high peak power loads with a DC grid inside of your building to save at the end energy and to reduce the peak power levels at the public AC mains. The production sites addressed in this webinar are using a high amount of electric energy, and therefore these buildings have usually an own power transformer for the connection to the public grid. The transformer is here illustrated at the left side of the diagram. The new detail for such a factory connected to the public grid is that once the AC power cable from the transformer enters the industrial building, there comes an AC to DC conversion. And the 650 volt DC voltage at the output of this conversion, you can see as the natural output voltage when you convert 400 volt three-phase AC mains into a DC voltage. More in detail, 650 volt is also the sum of the positive amplitude plus the negative amplitude of a 230 volt single-phase AC mains voltage. So that's the most simple explanation why you end up with 650 volt DC. Another interesting feature of the DC grid is that the power cables inside your factory will use 40% less copper to transport the same amount of electric power through your factory compared to a classical 400 volt AC mains voltages at the same apparent power level that you would transport with the AC cable. Yeah, to use the DC power then in applications, you would add circuit breakers. And once you have done that, then you can power your applications such as lighting installations or the robots or motor drives that we have mentioned before. To switch lighting on and off in these kind of applications, we recommend to use lighting controls. That can be also used to change the lighting levels of the lighting system manually or automatically from your building energy management controls. Lighting controls can be realized with a wired DALI bus system or alternative wireless lighting controls. And that has the nice benefit that you do not need to install extra wires for a DALI-based lighting control system. Yeah, so far this is a lighting system illustrated by sketches. Practically, we have realized such lighting installations with our LED driver prototypes that Indu have shown before at our own facility here in Eindhoven, as well as in 3 customer sites. And these testbed installations are running now since 2 years. Thanks to the advantages that we have built in the Xitanium LED drivers, luminaire designs for 650 volt DC power, according to the ODCA system description that you have seen on the slide before, require just minimal changes compared to the design of luminaires for classical AC mains voltages. And the most interesting differences in the luminaire design is a simple DC color code for the power cables according to this IC standard. And another detail There are some changes for a DC-powered luminaire, some adaptations on creepage and clearance distances that are described in another IEC standard. So the standards are already there. You only have to apply it to do a little modification on your luminaire design. Yeah, and also these details you can read in a publication in the German report at the German Organization of Electronic and Digital Industry, where we will also send you the link after the presentation. So, Signify is very proud to offer you this new titanium LED driver for more energy efficient DC power systems. Well, and this allows your customers to save cost, to save energy, and copper and power cables. So, do you want to manufacture luminaires for 650 volt DC power systems? If you want to do so, please contact your Signify key account manager for LED drivers and lighting controls. Organize individual meetings, if needed, also with the Signify experts. So that's the best way to have a face-to-face discussion on the special needs for your luminaire designs. And in that way, we are very welcomed to share our knowledge that we have learned in the last years on these kind of lighting systems. Yeah, with that, thank you very much for your attention.
Thank you, Ulrich. I see multiple questions here. So we'll take few questions. First one is, Ulrich, for you. It says, since the driver is non-isolated and input voltage is 650 watt, it has consequences on the luminaire structure. 650 watt LED modules are needed. And how about the terminal blocks within the luminaire? Typically, terminal blocks are related to 450 voltage. Are either of these available with us?
Yes, the terminal blocks are available. Yeah, we also use terminal blocks on our LED drivers, for example, that have these operating voltages. On the other side, it's important to remember that the 650 volt are not free floating in the electric system. Practically, we have only voltages that are plus 325 volt with respect to protected earth, and we have minus 325 volt with respect to protected earth, so the metal parts of the luminaires. And these technical detail in mind simplifies then also creepage and clearance distances.
All right, thanks for sharing that. I see another question. It says, looking at the specifications used for standard connectors and cables, are they okay with 650 watt DC voltage?
Yes, most connectors are okay with these voltages. Again, the voltage that we are operating with respect to protected earth are not higher compared to the use of 400 volt three-phase AC mains voltage. That's the interesting trick, that we convert directly 400 volt three-phase AC mains voltages within the boundaries of the voltage amplitudes into a DC supply voltage.
Clear. I see one question which is repeated in the morning also. It was asked. So the question is, do you also see future needs of 650 watt DC compact drivers? One sentence.
Yeah, that is an interesting question. And we think we can make such a compact driver. I think it requires some face-to-face discussions with you, what your really needs are, how such an LED driver should look like. And we are very confident that we could do also a mini driver, for example, for spots of lower power levels, but that should be discussed with you in a face-to-face meeting to go into the needs of your products.
All right. I see another question, which is a difficult one. Where can you find the product details? Well, that I can answer. You can find these details from the lighting.philips.com, or you can reach out to your CAMs. And after this webinar, we will also share the information package with you. So that's where you can find the details. We can take one last question. During design of lumen, do we need to take into account special requirements regarding circuit breakers? This was asked
Yes,
in the morning.
we have basically considered this for you. DC electric installations should have low inrush currents, and that we have taken into account in the LED driver design. So principally, the LED driver is doing most of it. Automatic circuit breakers for these DC grids are available with in different variants, and there are also special variants that also supports a further reduction of inrush currents. So thanks to the community of companies who have developed a 650 volt DC power system platform, there are multiple components that can support this and other topics of these kind of lighting systems.
All right. So there is one more question, which is for me, I guess. It's asking, do we have any plans to launch another power options? Yes, why not? If we have a solid business case, we will launch many more such power ranges. With that, I would say thank you so much for joining. Thank you so much for taking out time and sharing interest. I see so many questions which we haven't answered, but we will make sure that we will reach out to you. I sincerely believe that with this product, we will be able to help the world to be a more sustainable place. With that, thank you so much, team. Thank you, everyone.